Sorry. Okay, two types of functional dependency. We have two, partial dependency and also transitive dependency. So I explain the partial dependency. Usually, we can easily identify the partial dependency if the determinant is a primary key. Usually is a primary key. So this is the easiest way to understand the partial dependencies. Means that like student ID identify the student name. Okay. So like this, customer ID identifies the customer name. So this explanation is quite challenging to understand. So the functional dependency of customer name on customer ID and state is a partial dependency because customer name is determined by only the customer ID and state. So this is which is a subset of the determinant attribute customer ID and state. In this example, okay, in this example, you can see that they use two keys to identify the state. That is customer ID and state are used to identify the customer name. Okay, in this case, okay, it is not a wrong situation. You can use this kind of relation in the database if the situation is defined like that. Okay, so customer name. So they know that if they have multiple name, okay, multiple customer name, like John Smith is appeared 2 times, so that's why they need to have 2 keys, customer ID and also state, to identify the customer name. But basically, customer ID can be used to identify alone, identify the customer name. No need a state in some situation. But in another situation, they do need this combination of customer ID and state. But basically, I will explain the student that partial dependency has something to do the primary key. Means that the determinant is usually is a primary key. Easily can be a primary key. Okay. In other situation like, for example, student ID. Okay. And then we have student name, and the course fee. Okay. In this case, it is clear that student ID determine the student name, but not the fee. Okay, not the fee. But if we declare these two, student ID and student name, okay, become the primary key, both are primary key, then this can be used to identify the fee. So this is a challenging. Okay, sometimes it depends on the logic, but most of the time it depends on the situation of the data of the case study itself. Okay, so to be easy for you to understand the partial dependency, I would say that this is about the primary key. So let us have a look at the second functional dependency, that is a transitive dependency. Transitive dependency is a functional dependency where the dependent attribute is determined by a non-key attribute. The first one, partial, okay, dependent attribute is determined by a key, okay, primary key usually. But this one is determined by a non-key attribute. For example, the functional dependency of address on customer ID is a transitive dependency because address is determined by customer ID, which is a non-key attribute. Okay, customer ID determine the address. Okay, I understand that. You can always see the customer ID as a primary key. But in this case, maybe it is not a primary key. Okay, customer ID sometimes cannot be used alone to identify the address because one customer may have multiple address, right? So it doesn't fulfill the requirement to be a primary key that it can be uniquely identify the address. So that's why customer ID in this case is not a primary key. It is actually a non-key attribute in this case. Okay, customer ID and address, because there are not given another attribute like name, okay, phone number, like what, order, and so on. So customer ID cannot be used, is not possible to be a primary key in this case. So it become a non-primary key. Okay, when it is non-primary key, but customer ID somehow can be used as to identify the address, then this is a transitive dependency. Okay, dependency. It's quite challenging to understand these two types of dependency. Another example can be given like the activity, and also the fee. Okay, activity and fee. So like university activity can be used to identify the fee, right? Okay, but this cannot be a primary key. Yeah, but by logically it is not a primary key, but it can be used to identify the primary key. So this is a transitive dependency. Transitive dependency. Okay, so both partial and transitive dependency can lead to a data redundancy, yes, we know, and update anomalies. Not only update, but all the three anomalies. So by identifying and eliminating partial and transitive dependency, you can improve the efficiency, accuracy, and consistency of your database. So by looking into this summary, that data normalization, okay, has something to do with identifying the functional dependencies. Okay, we have two types of dependency, that is a partial and also transitive. Okay, so the process of data normalization, we do need to identify this partial and transitive dependency, because we know on data normalization we need to what? Reorganize the database structure by creating a new table, by separating a tables and so on. But how can we separate the table? How we can break down the table? Okay, so we need this two. Okay, by having these two, then we can separate the tables to improve the consistency of the database itself. So this is the process. So before I proceed with the data normalization process, I need to continue with some explanation on the partial dependency. Another example, in a table that stores employee information. So the functional dependency of employee name on employee ID department is a partial dependency. Partial dependency, because employee name is determined by only the department ID and also employee ID. Okay, employee ID. So in this case, employee, there are two primary key, employee ID combined with the department. Okay, department is used to determine the employee name. Employee name. So this is partial dependency. Okay, in many times students use to create like this, employee ID determine employee name. Tak salah this is also correct, but as I said, that depend on the situation, depend on the case study given. Okay, sometimes it does require more than one key to be a primary key. Okay, but if it is can prove that employee name can rely on the employee ID, then you can proceed. Okay. So in this case, these two is an employee ID and department. One is clearly is a primary key, but this one like a non-primary key. But when they are combined, okay, both can be is a primary key, so it is an example of partial dependency. It can be used to identify the employee name. Okay, this is example I take from the internet. Partial dependencies and also transitive dependency. Okay, you can see here a partial dependency is a functional dependency in which the determinant is a part of the primary key. Part of the primary key can be a part of the primary key. While the transitive dependency is a functional dependency in which none of the attributes involve attribute of a primary key. Usually they are not a primary key. In this example, activity is used to identify the fee. So this is a transitive. Okay, transitive. Transitive. Okay, and this part student ID is combined with the activity to identify the fee. Okay, logically student ID cannot be alone use the fee because we do not know the activity, what activity they involve. So that's why they combine the student ID and activity. Okay, they combine these two and then it can be used to identify the fee. Okay, given to the student of participating the activity. So the same situation, activity, student ID, okay, but it gives the situation. First is a partial dependency and second is a transitive dependency. Okay. Look again, I explain to you. Look at here. Okay. No. So look here. This, okay, these two is used to identify this one. So one of it is clearly is a primary key. So that's why it is a part of the primary key or subset of the primary key. Okay, so this is a primary key, this is not, but these two now is used together to identify this fee. So this is a partial dependency. But another case, we do not likely we just want to know that the fee for activity without relating to the student ID. So we use activity, okay, to identify the fee. So in this case, this is a transitive because activity alone is not a primary key. So it is a transitive. So there are two situations here. One, this is to identify how many fees, okay, the student encountered a charge to the student with that activity. One situation. And this situation is we just want to know that how many fees involved for that that activity. Okay, one activity. Okay, so this is the dependency, transitive, and also partial. Another example. Okay, in a table that stores order information. Look at this. This is a order information. Okay, order information. Okay, order information. The functional dependency of shipping address on customer ID is a transitive dependency. Because shipping address is determined by customer ID, which is a non-key attribute in that case. So this one, customer ID, is used to determine the shipping address. Logically, you can say that customer ID can be used as to identify the shipping address because customer ID is always a primary key, but not in this situation. Okay, if you will look carefully, customer ID and shipping address is something different. Okay, customer ID is ID customer profile, but shipping has something to do with the order, not the customer ID. Yeah, customer ID, customer is related to the order, but shipping address are more close with the order rather than the customer itself. So it depends on the order information, not the customer information. Even though address will be appeared in the customer ID, okay. But somehow in the order information, we do have a shipping address. But in the customer ID may be only a customer address because sometimes we do deliver the order in a different address, right? Different address. So customer ID is a non-key attribute in this case because it does not uniquely identify a row in the table. Means that it does not identify the customer ID. Okay. So this is because customer ID is not the primary key of that table. The primary key is an attribute that uniquely identifies. So the order ID should be the primary key. So, but then in this case, customer ID is used, not the order ID. Then we can say that this is not a primary key. This is not primary key. So when it is not primary key and is used to identify the shipping address, then they falls under the category trustive dependency. If in another situation that is order ID used to identify the shipping address, then this relation falls under the what? Partial dependency. Because it is clearly this is a primary key in this case, but not in this case is not primary key. Okay. We do not change the situation. We do not change the relation. Remember that one. If what I mean by we do not change the relation is still the same. The relation is there. We do, because they said that in that case, customer ID in that situation, it is used to identify the shipping address. Yes, it's okay, but it falls under the trustive dependency. Bila dia dah jatuh kepada trustive dependency, adalah caranya macam mana kita tak nak dia dalam kumpulan ini. So remember that the previous lecture, I said that we need to eliminate, right? Eliminate partial dependency and also trustive dependency. So eliminate. So how to eliminate? So we break into the table and so on. Okay, so this means that if you know the customer ID, you can determine the shipping address, but you cannot determine the customer ID if you only know the shipping address. So this is how they explain the trustive dependency using order information situation. Okay, so this is a recap about a non-key attribute. Is an attribute database that, but it's not part of the primary key. Okay, and it is used to store additional information. And in a table, non-primary attributes can be either single valued or multi-valued. Okay, so this is only the revision. Primary key should determine all attributes. No subset of the attributes in primary key is a candidate key. A key consisting of more than one attribute is called a composite key. Okay. Foreign key, yeah, foreign key. This is foreign key. Okay, I would like to proceed with the normalization process. 3 steps, okay, under the normalization process. Okay, the normalization process involves the following steps. The first is to identify the functional dependency. Look, the first process is to identify the functional dependency. So in this, the first very beginning step is if you receive a structure of unnormalized data, then you need to identify the two functional dependencies, transitive and also partial dependencies. And then after you recognize, after these two functional dependencies are identified, then it's the time for you to divide the database into smaller table. It means you need to break down the table depending on what you obtain during the functional dependency. Okay. Then next is after you divide the small tables, then a new attribute, new primary key, new key for each table must be defined. So please, you need to very careful in this part. Okay, you need to place each attribute in the table where it is functionally dependent on the primary key. Means that you are required to identify a new primary key for the new created table. And then repeat steps 2 and 3 until the database is in the desired normal form. Okay, desired normal form. Okay, in the last previous lecture, remember that I gave you this kind of example where they put everything, almost every information in this table. Okay, in their database structure. They only have one single table in their database. So by having this part, so means that you need to identify which one is transitive, which one is a partial, like this or like this. Okay, so it depends on the situation. Okay, so after that, after you are finished the identification, okay, then you need to break down the table. Okay, break down the table. This, okay, for example, you identify that this can is used to determine this one and this one, so means that this is one table. Okay, this one is another table, and this is another table. Okay, another table. So like this. So this is what it means by step number 2. This is what will be done in step number 1. And then finally, if you have this one, then you need to create, no, not create. You need to assign a primary key as usual. Because you know that for each table, they need a primary key. Okay, you need a primary key. So this is a common requirement of a database. So this is the process. Okay, 1, 2, and 3. Important. Identify the functional dependencies, and after you finish the identification, you divide the table, means that you break down the table, and then finally you fulfill a database normal requirement, that is to identify to assign the primary key. Primary key. So that is a step. The step. Okay. Now let's go to the conversion to the first normal form. First normal form. Do you remember the normal form? Okay, the first one is unnormalized, right? Unnormalized. Okay, and then we go to first normal form. 3 is second normal form. And 4 is the third normal form. The most normal. The most normal. So one normal form. One normal form. Okay. This one, they deals only with the transitive dependency. Transitive dependency. They deals with the transitive dependencies. And after they finish with the transitive dependencies, they are said to be in a first normal form data. Means that they do not have any trustive dependency. Okay. And second normal form is it is in a condition of one normal form with no sorry, this is a partial dependency, and this one with no trustive dependency. Okay, so they make things clear. Means that in first normal form, they are actually removing or eliminating all the partial dependency. Okay, after they are finished completing removing all the partial dependency, then they said they are in a first normal form state. Okay, first normal form. They remove all the partial dependency. Okay, now in the second normal form, what they do is to eliminate the trustive dependency. So when they finish eliminating the partial dependency and eliminate the trustive dependency, now they are in the third normal form. Okay. All right. So this is a summary from 1 to the third normal form. Okay. Conversion to the first normal form. Repeating group. Group of multiple entries of same type can exist for any single key attribute. Relational table must not contain repeating groups. So normalization table structure will reduce data redundancy. Okay. Eliminate the repeating groups. Eliminate nulls. Each repeating group attribute contains an appropriate data. Step 2, identify the primary key. Okay, we need to ensure that the primary key must can uniquely identify attribute value. And here, new key must be composed. And step 3, identify all dependency. Usually, we use a dependency diagram to show this situation. Okay, like this. A table. This is a table in a first normal form. Okay, we have a project number, then project name, employee number, employee name, job class. Okay, charge hour and hours. Hours may be the work hours. Okay, so this is data in a normal form. Usually, it is like this. Remember when you go outside in a small shop, very conventional shop, okay, they require you to write down your name and so on after do some transaction with them, or like a logbook when you attend to some room, okay, attendance when you enter some lab, okay, so there is a book there, and then they provide like this situation, right? This is a book and this is attendance. It's a log book, so they need to write the number, your name, time, maybe class, and so on. They put everything, almost every important attribute in that one single table. Do they have a table name? Can you recognize? Can you remember? Biasanya tak ada table name kan, cuma ada buku saja without a table name. So they just said that this is an attendance book, okay, but they put everything relating to the attendance in a single book. So we can say that if we extract the information like this into the database structure, we can have the number here. Okay, we can have a name, maybe ID, okay, staff ID or student ID, and then time in, okay, time out, and what else? Maybe the class name, related class, and what else? The signature, right? Signature. So we can say that without the table name. because we already extract this into the database format. So usually in database we do need a table name, right? Table name, but in this case, no table name, no primary key is assigned. Kan? Jadi, so this is situation. So we can say that this is a unnormalized form. This is an unnormalized form. So same with the example. Same with this example. In their spreadsheet, they have a project name. So now we extract it into a database, project name. Sorry, this is a project number, project name, employee number, employee name, job class. Sorry, for my bad writing. Charge hour and hours. So this is in a database form. Again, there is no name, table name. Remember, table name is a relation name. This is important. And then there are no primary key, no foreign key can be extracted from this information. We just have this one. Okay, so this is another example of unnormalized form. So what do we need to do? The next process, first, unnormalized form, we need to extract it in the database structure. Second part, second step is to what? Identify the functional dependency. Functional dependency have to partial and also transitive. Okay, and we are using this kind of diagram, so we say that we acknowledge this diagram as a dependency diagram. Dependency diagram. So the dependency diagram depicts all dependencies found within a given table structure. Within given table structure, it's very helpful in getting bird's eye view of all relationships among the table's attributes. Makes it less likely that you will overlook an important dependency. Okay. If you wanted to use a schema, also can. Okay. The first dependency diagram is like this. It's like schema diagram. You remember we have two types of schema again. Schema. First one, we use this form. Okay. And second one, how? Table, the name, right? Name and also attribute. Remember this one? Attribute 1, attribute 2, and so on. This should be the same. Okay, so dependency diagram, basic of that dependency diagram is like this. So we use this one. And also you can also schema form like this. But sometimes it's more easier to use the dependency diagram rather than this kind of schema form. Okay, this is the example. Okay, so first normal form. Okay, before we proceed with the first normal form, we need to remember the first step just now on the unnormalized form. We extract the information, okay, from the given case study into this table form. Okay, table form. Okay, and then we need, after finish extracting the attributes, all the attributes, okay, we need to identify the functional dependency. In this case, they identify the project number, identify the project name, determines the project name. Employee number determines the employee name, job class, and charge hour. Okay, and project name, employee number is combined as a composite key to identify almost all employee name, job class, charge hour, and hours. Okay. Since how do they know that this is a partial and this one is a transitive? Okay. Project number is usually is can demonstrate that it is a candidate for the primary key. So this is a primary key project name. So this one, when the project number determines the project name, so this relation is a partial dependency. They do name this relation as a partial dependency. Okay. Next, employee number. They say their employee number has something to do or can be used to identify the employee name is their job class and their charge hour. Why this is a partial dependency? Because employee number is a candidate for the primary key. It can be a primary key because it can be uniquely identify these three attributes. Okay. So this is a partial dependency. On other situation, they to combine the project number, employee number. So that's why they can include the hours. Hours, I think not much information is given based on this diagram only. Maybe hours is a time, the hours they take to finish the project. Charge hour is like the charge for each per hour, okay, per hour. So they need to combine the project number and employee number to get the hours required or hours taken to complete the project. So that's why they need to combine these two as a primary key to identify all of this. Okay, so this is also the actually the partial dependency. On the other hand, if we look carefully, the rest, okay, we have employee name, nothing to do with the employee name except it is related to the employee number and the project, and the job class and charge hour. This has some relation because maybe the job class like position, the position determines the charge per hour. Okay, the charge per hour. But we know that job class is not qualified as a primary key alone. Okay, primary key alone. So this is a non-primary key. So but the job class can identify the charge hour, but it is not fully qualified to be a primary key. Usually primary key, right? Primary key determines the other key. Okay, but this one, they are not qualified as a primary key, but they can, job class can identify the charge hours. So it falls under the trustive dependency. Trustive dependency. Job class and charge hour. Okay. So we finish with the dependency diagram. So we finish drawing. Drawing here means identifying the things. We think and then we try to look out what information has been given, and then we logically think that this is the dependency they have. Okay, after finish looking at this one and identify these two dependency, then you need to rewrite it. Rewrite. Okay, rewrite like this in the schema form. Okay, and schema form like this. So 1 and F, project number, employee number, project name. Okay, project name, employee name, job class, and so on. Okay, they just rewrite it into, so they pull out the primary key into the left part. Okay, right. Then from the diagram, they extract, they write down using this schema form. This is table form. This is a schema form. Partial dependency. They have two partial dependency. That is the first one coming from here, and this one. This one. Okay, no. Dah belajar. Okay. Okay. Partial dependency. Okay. So another one. Okay, they finish with the partial dependency and trustive dependency. Trustive dependency. Okay, now they have partial dependency and also transitive dependency. So this is what we obtain from the first process round on the normalization. So next what to do? Kita sekarang baru identify je. We just identify it, but we do not yet complete the process. This is our first round. Just identify and rewrite what we obtain, what we can extract from the diagram. And the extraction is based on the dependency you found, the two dependency. But not every time you can get this partial and transitive dependency, especially transitive dependency. Okay, sometimes they already fulfill the partial dependency and they just obtain the transitive, or another time they can obtain these two dependency. Okay. So first normal form, describe tabular format. All keys attributes are defined, no repeating group, and so on. So all relational tables satisfy first normal form requirement. So some tables contain partial dependency. Dependency are based on part of the primary key. So now step 2 is to convert it into the second normal form. So make new tables to eliminate partial dependency. Saya rasa saya dah terbalik tadi. Second normal form is to eliminate the partial dependency. Sorry. Okay, we have unnormalized form and then first normal form. Okay, first normal form is when you have these two partial and transitive dependency. Second normal form is to eliminate partial dependency. Third normal form, eliminate transitive dependency. Then it is okay. It should be okay. So first normal form, they still contain the two partial and transitive dependency. That means that it still contains partial dependency and transitive dependency. So the step, make new tables to eliminate partial dependency. Second is assign corresponding dependent attributes. Okay. This is the result from the second normal form. You can compare it from this one. Okay, sebelum ni kita dah buat macam ni kan. First normal form and partial dependency. This is the result from the first normal form. Wait, okay. I erase. Okay. So this is the result from first normal form. Now we have this. So to move to the second normal form, okay, then we take this information, okay, and we create it. Okay. So now we have project number. We say that project number identify project name. So project number, project name, right? This is in a table format. Sorry, schema format. What missing? What missing? Usually we have table name. This is a table form, table form. So primary key, attribute 1, attribute 2. Or we have a table name or relation. Primary key, A1, A2. So this is a common requirement of database structure. Okay, so now we have like this. Yeah, from here, can you see? Project number, identify project name. So this two actually is an attribute in a table, okay? So we write like this, project number, project name. So what's missing? What's missing? So one missing is the name of a relation or a table, Second is a primary key. Primary key can be easily, because here you said that project name identify project number identify project name. Of course, project number now will be a primary key based on this identification. Just you need to write down the table name. So we can say like the name of the table is project. Example. Okay. Second, employee number identify this, and this. So here you write down employee number, then employee name. What else? Job class, and then charge hour. I shortened the name. Okay. So you know here, employee number determines employee name, job class, charge hour. So of course, employee name in that situation is a primary key. So you just give it a primary key. You upgrade the employee number as a primary key. And then give the name of the table employee. Okay. So are you clear with this part? So this is a second normal form. Remember, second normal form is to eliminate what? Transitive dependency. No, partial dependency. Eliminate partial dependency. Okay, so now saya tunjuk. So now you have your first table tadi ni dah jadi second normal form. Means that you dah ada project with that ni kan description, employee, this one. Okay, but then you don't finish the transitive dependency. So from 2 and F means that you have project this one. This is a new table, new declaration of a table based on the partial dependency. Okay, but then what left is transitive dependency. Transitive dependency is there, still there. That is a job class with the charge hour. Okay, then from here, of course, you can move to the third normal form. Just carry this portion to here and do the same thing. Then you finish the third normal form. When you do repeat the same thing. But then this is a transitive dependency. Okay, job class, charge hour. So how do you identify is the primary key for this? We said previously that job class is not relevant as a primary key. So how do they write? Okay. So it is like this. Okay. This part, job class. Okay, job class, transitive dependency. Okay, transitive dependency. Okay. In this case, looks like they do not care very much about the charge hour, even though the job class, okay, is used to identify the charge hour. Okay. For if in other solution, we can change the transitive dependency like this. We create a new job ID, okay, and then we have a job class, and then take a charge hour. Okay, this also can be done, and we update job ID as a means that we introduce new key as a primary key in this to solve the transitive dependency. Okay, Trustive dependency. But in the solution from this book, okay, they provide other solution, that is, they just put the job class and charge hour into the employee, despite into the employee table, and they create a new table named as a assignment. And assignment, they take the two primary key, project number, they combine with project number and employee number, and give a assign work, assign hours. So I do not have a detail from their solution. Okay, when I see the assigned hours, it means that the charge hour is not what I mean. I mean that this is charge for per hour for the job class, but it seems they have a different view of that. Maybe this charge hour is how many hours is allocated for the job. The hour just now previously is hours taken to completed, but this one is the assigned hours. Means that how many hours they allocated for this job. Okay, so that's why they create a new table like this, and they change it into an assignment by giving the project number and employee number, and give the assigned hours. This also can do. So that's why I said that it very much critical with the supporting statement or supporting description before we can give the means that the outcome you have will be very much dependent with the information provided. Sometimes if we just use our logic, then it might be misleading. Okay, it might be misleading because without looking for any information, if they just give this table, if they just give this part, this information, so I may end up with this solution by creating this job ID class, because I think charge hour is charge per hour for that job class, but they give solution like this. Maybe they think that this is the hours allocated for the task or the job. Okay. So in the examination purpose, so it is very much to refer back for what information given, and if they state that you can use your assumption, then you can use your assumption. If not, you need to follow every single thing, every information provided. So no need to create or recreate logically, okay, or any assumption. Okay, so that is the stable. Now is the conversion of the third normal form. And now make new tables to eliminate transitive dependency. So for every transitive, write its determinant as a primary key for new table. Okay. They assign corresponding dependent attributes and name it. Sorry. So this is the final. Okay, final result of the third normal form. In this final result, look, this is a very new, the new table assignment. They give table name is assignment. This is from the partial dependency. These two coming from the partial dependency, and these two coming from the transitive dependencies. Yeah, they give two job class and charge hour. But for me, I will give a new ID. Sorry, new attribute. But maybe they just only use what they have, so they do not provide, or they do not give a new attribute here. Previously, I give a new the new key. Okay, that is a job ID. Job ID here. Job ID. Both is okay. Means that sometimes, yeah, maybe in the examination you are restricted to create new attribute, okay, somehow. But if it is allowed, then you can create it if it is necessary. Okay, so improving. So what you do is improving the design structure of the database. So the table structure should be cleaned up to eliminate initial, partial, and also transitive dependency. Normalization cannot by itself be relied on to make a good design valuable because it's eliminate only the data redundancy. So what are you doing now is actually reconstructing the database to, yeah, the main thing is to reduce the redundancy. How to do that? By identifying the partial and transitive and recreate the table. Recreate the table basically based on what they provide. Okay, issues to address in order to produce a good normalized set of tables. Evaluate primary key assignment. And then you need to evaluate naming convention. Sometimes it's misleading also. Refine attribute atomicity and identify new attributes. See, this one is identify new attribute if necessary. Okay, another, identify new relationship like just now. They have a assignment, right? There is a new relationship assignment table. Refine primary keys as required for data granularity. Refine primary key. Then maintain historical accuracy. Evaluate using derived attribute. So this is how we can we improve. How we improve the design, database design using the normalization. This one, the completed database. This is another exercise. So surrogate key consideration is an artificially generated key. So when primary key is considered to be not necessary, not suitable, okay, designers can use a surrogate keys. So data entries in that table 6.4 are inappropriate because they duplicate existing records. So no violation of entity or referential integrity. So that's why they do the surrogate key. Okay. Job code, job description, and so job charge hour. So you can see that the value is the same. So they have the duplicate entries in the job table. Next table is the third normal form, perform suitably in business transactional database. Okay, higher order normal form are useful on occasion. So two special cases of 3 and F is B, C, and F, and fourth normal form. Remember that fourth normal form is long before. Now they have a sixth normal form. But again, I said that third normal form already performed in any common business transaction database. Okay, sometimes the higher normal form doesn't mean that it can be very efficient. It can create another challenge. Okay, too normal is sometimes not too good. Okay, this is the BC and F. Sorry. Okay. Every this situation is boys code normal form BCNF. Every determinant in table is a candidate key but has same characteristic as primary key, but for some reason not chosen to be a primary key. So when table contains only one candidate key, the 3NF and the BCNF are equivalent. Contains only one candidate key. So BCNF can be violated only when tables contain more than one candidate key. So most designers consider the BCNF as a special case of third normal form. Table is in 3 and F, third normal form, when it is 2 and F and there are no transitive. So table can be in 3 and F and fail to meet BC and F if no partial dependency, nor does it contain transitive dependency. A non-key attribute is the determinant of a key attribute. So So this is the situation. The simplest way to explain the BCNF is non-key. There exists a situation that the non-key identifier can be used to determine the primary key. This one, this part. This is C is a non-key logically in the diagram, but that this happen that C can identify B, whereby the B is a primary key. So this is a BC and F. Okay, the situation of BC and F. Sample, student ID, staff ID, class code, and enroll. Great. So this one, it is 3 and F, but not BC and F because the C here, okay, happen to identify the B, which is the B is a primary key. So that's why this one, this situation is said to be BC and F. The solution is the same, okay? It just we recreate or we introduce a new primary key so that the C can be upgraded as a primary key, yeah, by somehow combining with other primary key. So we can upgrade it into a primary key, the solution. Okay. And the last part is a fourth normal form. Okay, normal situation. All right. Are you okay, guys? So I cannot see you, so I cannot see your expression, and somehow I cannot detect your understanding. But I hope somehow you can understand the process. Okay, the process of data normalization. Okay, I think I should stop here in this part. So then next week we will have an exercise. I will give an exercise and then we can do the process normalization again to improve your understanding. Okay. But then I would summarize again what you learned today. Okay, what you learned today. Sorry. This is first normal form, unnormalized form. You obtain the unnormal form, okay? And then first normal form, this is where you identify the partial dependency and transitive dependency, identify process, and then after you can readily identify these two dependency, then you can start the normal form. Second normal form. Second normal form is to eliminate partial dependency. And after finishing this part, then you move to the third normal form. That is, you are now in second normal form, plus you need to eliminate the transitive dependency, and it's done. Third normal form. And if you identify that there is a non-key identifying the primary key, then you are in the state of a BC and F. Okay, BC and F. BC and F. Okay. So how do we eliminate the partial dependency and transitive dependency? Okay, just rewrite again. After you identify, then write in a form. Okay, in a schema form, and then give a table name, meaningful table name, and assign the primary key like a common database table. Okay. Any question? Are you still with me?
Yes, yes, doctor.
Yes. So how about next week? Do you have face-to-face or online class?
Online.
Online. Okay. One student representing 112.
Online, madam.
Okay, so if that you said that, so yeah, for now I decide it go online, but if you need face to face, then please tell me. Okay. Right. So any questions so far? Okay, attendance, I will enter the attendance based on the team's attendance. Okay, so if there is no question, thank you for today. But sorry, I lambat recording. I delayed the recording. I forgot to record it in the first 5-10 minutes. So, right, you can find the recordings in the Teams. Okay, thank you for today and Assalamualaikum.